All right, let's move on with our discussion with binomial random variable. Here is one example. Again, just like all other videos, I am trying to skip videos just to keep these videos shorter. All right, practice problems. There are special cases when p is equal to 0.5, when n is odd, 7, you are going to have the two middle numbers for x have same weight. And when n is an even, you are going to have just one mode, all right? Or the middle number is going to have the highest probability. So just a special case. Applications, there are a bunch of applications. So I encourage you to have a look at these in this link, and for the applications we will discuss them in more details as well. So pretty much in any situation that you deal with customers showing up or not, students arriving on time or not, students getting COVID or not. So all of these situations that they have Bernoulli experiment type, all right, uh, you can at least the starting point for modeling number of occurrences, number of things that happen. Oftentimes, starting point is a binomial random variable. All right, so practice problems. Let's move to geometric random variable. So here's one example, and I'm going to read just from a slide. A coin has 60% chance of landing head. You flip the coin until you observe a head. See, in this one, you don't flip it certain amount of times. You flip it until you see one head, the first head. All right. What is the probability that number of trials needs to be in trials needed is equal to 1? Well, if I want to get the first head, first one, x to be equal to 1, first one must be head. All right. So what is the probability? 0.6, right? What is the probability that number of trials needed is equal to 4? Well, if I want 4 trials to get to the first head, the first 3 must be tail. So what is the probability of that? First one tail, 0.4. Second one tail times 0.4. Third one tail times 0.4. The last one must be head times 0.6, right? What is the probability that number of trials needed is equal to x? Well, it's going to be, if I extend this example, it must be 1 minus p to the power of x minus 1 times p. Let's see if we got this right. All right. Probability that x equal to x is equal to 1 minus p to the power of x minus 1 times p. Well, how do we define Bernoulli? I'm sorry, geometric random variable. Geometric random variable measures number of experiments, number of repetitions until we get to the first success. All right. There's a fundamental difference between geometric one and binomial one. Binomial one, you flip it a certain amount of times and you count number of successes. In geometric, you don't know how many times you are going to flip. All right. So you flip until you repeat that experiment until you get to first success. So number of success is always 1, but you know how many times do I need to repeat to get to that first success? Well, random variable that is geometric measures or count number of experiments needed, and probability that you need x experiments is equal to 1 minus p to the power of x minus 1. First x minus 1s are failure times last one must be success p. All right. Expected value calculation, it's 1 over p. All right. And I'm going to cover these intuitively in class, but for time being, I want you to understand these concepts. That's all. Geometric, so let me move on. Practice problems. All right, so the rest, it's going to be a little bit trickier, so I'm going to record another video for negative binomial and moving forward.